Hey ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 5 Notes 1. So we're going to be talking about finding the vertex and the y-intercept. So today we're going to be basically identifying different parts of a parabola. So let's start by talking about what a parabola is. So a quadratic equation is anything that can be written in the standard form ax squared plus bx plus c. Okay, so that's the standard form of a quadratic. Quadratic always have a degree of 2. Okay, and the graph of a quadratic is always a parabola. Okay, so last unit we learned how to factor, and that was one way we learned of solving quadratics. Now this unit we're going to be working more with quadratics and figuring out where we can take these quadratics. So let's go ahead and let's take a look at some parabolas here. Okay, so first of all, okay, they have a point called the vertex. This is the starting point when you graph a parabola. So make sure you fill in vertex on that bottom line there. This is the maximum or the minimum for the graph. So on this parabola right here that's opening upward, that point right there at the very bottom is the vertex. And since it's on the bottom of my parabola, that makes it a minimum. Then if we look over here, that point right there, that's our vertex for this parabola, but this time it's at the top of our parabola, which makes it a maximum. Okay? Also, within these graphs, we have, let's get rid of this here. Next. So next we notice that the parabolas are symmetric. So they have a invisible line going through them, but we actually draw it as just a dashed line going through it. And that's known as the axis of symmetry. So the axis of symmetry is right here, and I'm just going to abbreviate that AOS because you'll see that every once in a while. So that's our axis of symmetry. So this runs through the vertex, and basically it's going to be cutting your parabola in half. Okay? And it has the same value as the x-coordinate. Next, okay, the point where the parabola crosses the y-axis is known as the y-intercept. So this point right there, this guy right here is the y-intercept. And this point right here, you've worked with the y-intercept before, okay? That's just where it's crossing the y-axis. So this is known as the constant of the quadratic function. So the constant is that number c. So it's the thing that's just a number. That's also your y-intercept. Lastly, let's take a look at this last part. The graph will open up. So that's like this first one right here. Okay, the graph will open up when your a coefficient, that coefficient with the squared term, is greater than 0. And it will open down when that a coefficient is less than 0. So think of it this way. If your a is positive, you're a happy person, you're going to be upbeat. It's going to look like a smile. If you're a negative person, you're going to be kind of down, and it's going to look like a frowny face. So that's kind of a way you can tell between whether it should open up or down. Now let's take a look at some of the steps for finding what we need, basically the vertex. That's the most important part of a quadratic when we're graphing is the vertex. So, steps to finding the vertex of a parabola in standard form. So first you need to figure out what your a, your b, and your c are. That just comes from the standard form of a quadratic. Then you need to find the x-coordinate. So that's given by the equation x is equal to opposite of b over 2a. So that's a formula that you're going to use, is x is equal to opposite of b over 2a. Once you get your x-coordinate, you can plug it back in for each of the x in the original equation to figure out what your y is. Then you'll have a point x and a point y, and you can write out the vertex as a point x, y. So to calculate the axis of symmetry, you're going to use the same formula as you do for the vertex, for the x-coordinate, because the x-coordinate of the vertex does represent the vertical line of the axis of symmetry. So the two formulas are actually the same. So let's go ahead and let's take a look at putting this into practice. So for number 1, I want to calculate out my a, my b, and my c. So my a is going to be 2 because it's with the squared term, my b is 8 because it's with the x term, and my c is negative 3. So next what I notice is that my a is positive, so it's going to open up. So now I want to calculate all my axis of symmetry. Well, to do that, I'm going to use that formula opposite of b over 2a. So I say opposite of b because if the number is negative, you need to make it positive. So you need to do the opposite of whatever b is. Well, here I have a positive 8. So then I'm going to do a negative 8 divided by 2 times a. I always suggest that you guys simplify out the denominator first. Okay, so I suggest that you simplify this out. So then you're going to have negative 8. And then you're going to have divided by 4. I apologize, I have reminders coming up all over the place. Okay, so then you have negative 8 divided by 4, which is going to give you a negative 2. So x is equal to a negative 2. So now we're going to take that negative 2 and we're going to plug it in for x up here. Okay, so we're going to take each of those x's out and we're going to go ahead and plug those in. So I'm going to take x out and I'm going to put 2 in instead. So wherever I see an x, I'm putting 2 in instead. Okay, so now you can go ahead and exactly as I have it written, you can plug that into your calculator. So use the parentheses, use everything like I have it written, and then what you end up getting is negative 11. So let's take a look at what we've discovered here. So our axis of symmetry is going to be at x is equal to negative 2, using that formula. Our vertex is going to be negative 2, negative 11. Last but not least, to calculate out our y-intercept, remember your y-intercept is just your c value. Next, let's go ahead and let's take a look at number 2. So for number 2, our A is negative 3, our B is negative 6, and our C is 4. So because our A is negative, it's going to open down. So then for our axis of symmetry, we end up getting x is equal to opposite of b. Well, since my b is a positive or negative 6, I'm going to make it a positive 6 over 2 times a. Remember, I want you to multiply out that denominator. You can't just type it all into your calculator. You have to multiply the denominator out separately. 6 divided by negative 6 is negative 1. So x is equal to negative 1. So where I see x up here, I can plug in negative 1. So I'm going to remove x completely, and wherever I see an x, I'm plugging in that negative 1. I always use the parentheses because that helps to maintain the validity of my negative numbers. So how I have it written here, you can plug that exactly into your calculator. And when you do that, you end up getting 7. I suggest you type it in your calculator. Make sure you're doing it right. If not, then you can show me what you're doing tomorrow. We can make sure you're on the right track. So it's really important that you calculate along with me. Otherwise, you won't know that you're doing it wrong till probably the quiz. So make sure you're calculating it along with me. So then you get that x is equal to negative 1. So then your vertex is negative 1, 7. And your y-intercept comes from your c value, which is 4. Next, let's take a look at number 3. So for number 3, what we want to do is calculate our A, our B, and our C. Our A is 1, our B is 2, and our C is 18. So to get the x-coordinate of our vertex and the opposite of their our axis of symmetry, we're going to do opposite of B over 2 times A. So that ends up being negative 2 over 2, which is negative 1. Okay, so this is going to open up because my A is positive. So now I've calculated out my axis of symmetry, and I can use that to get the y-coordinate of my vertex. So what I'm going to do is I'm going to remove x completely, and wherever I see an x, I'm going to be putting a negative 1. And I always put it in parentheses. So please make sure you try practicing this on your calculator yourselves as well so you know how to do it. All right, so when you plug that in your calculator, you end up getting 17. So then our axis of symmetry is just x is equal to the whatever our axis of symmetry is, and then our vertex is our x-coordinate, and then our y-coordinate. Our y-intercept is our c value, which is 18. Let's go ahead and let's take a look at this last one. So this one trips students up because they just assume that because that 16 is the second term, that 16 is B. And it's not, because that 16 doesn't have an x with it. So my A is 2, but my B is actually 0 because we don't have an x term. So that makes my B 0. So now I need to calculate out my vertex. So I get x is equal to the opposite of B over 2A. Well, the opposite of 0 is really just 0. So I have 0 divided by 4, which is 0. So my axis of symmetry is that x equals 0. Again, it's opening up because our A is positive. Next, what I need to do is I need to plug in x is equal to 0 into my original equation. So whenever I see an x, I'm going to replace it with a 0. So I have 2 times 0 squared plus 16, and that gives us 16. So then my vertex is 0, 16. My y-intercept then is 16. So that concludes your note video today. Please make sure you take that Schoology quiz once you're done. Thanks for listening.